Hi everyone, welcome back to this channel. So I thought I'd try something a bit different today. So as well as learning languages, I also, past 2 years, have been learning how to program. And I've been making a chess game for anyone who is a beginner to chess and wants to learn the game. It has lots of tutorials, it has tools that show you various things and positions like attacked pieces, pinned pieces, things like this. It's not quite finished yet, but it's almost finished. That's all for the shameless plug. Because of this, I kind of have a slight expertise, I guess you could say, in learning programming languages and regular languages. So what is the difference? What is the main difference between languages, well, programming languages and regular languages? Of course, they have the name language, but what else is the difference? Let's have a look. First, let's cover the similarities. So they both use words, I guess. They both have rules, and they both have errors and mistakes. But that's almost the only real similarities they have. The rest of it is almost entirely different. They have entirely different rules, entirely different mechanics. One of them requires a lot of context, and one of them you have to be very specific. So they're very different. So for example, one of the main differences is actually the size. If you take the size of most languages, like most regular languages, it's like thousands, tens of thousands of words you need to know. Whereas programming languages depends, but normally a lot smaller. Take the C programming language, for example. It has about 40 keywords, and keywords are like instruction words or words that you can't name certain things because it's like a command in some way. There are only 40 to learn, so it's a lot simpler than regular. There's a lot less to learn in most programming languages, but you need to understand how they work. But it's not necessarily the amount that makes it difficult, it's understanding how to use it as well. So let's look at a summary of both and compare them. So regular human languages consist of types of words. For example, we have verbs, adjectives, nouns, and we combine these to make sentences. We also have questions, commands, things like this. We also have rules. So the rules could be things like grammatical gender, it could be word order, it could be verb conjugation, it could be lots of things. One of the key things about human languages, it's very, very context dependent. So lots of things depend on context. You don't necessarily need to specify lots of information because you can understand through context. One of the best examples of this is actually the Japanese language, because Japanese is extremely context sensitive. They don't even use pronouns half the time, and the verbs don't change for person, and you guess from context. Take for example let's go in English. In Japanese they would simply just say iko, which is just the imperative form of go. So just go, and you understand what it means through context. So it could mean we go, let's go, you go, they go. It's just context, all it is. This is one of the fundamental differences between programming languages and regular human languages, because you have to be very specific in programming languages. Normally the computer can't guess what you're thinking, whereas you can normally guess from context in human languages. But here's a summary of programming languages. They are used to talk to computers. They have lists of different types of words. For example, we have variables, which are basically ways of storing data, and there's different types of these. Integer, boolean. Integer is a whole number, boolean is a true or false, string is text. Then we have various different commands we can use. We have if statements, loops, and in some languages we have classes, which is basically like a holder of variables and functions. So in general, programming languages don't contain too many words. This does depend, because some can be a lot more complicated than others, but in general there aren't too many words to learn. So there are rules similar to grammar rules in modern languages in programming language, and it's called syntax, which is things like word order, how to differentiate different instructions. So it could be different lines, it could be semicolons. It generally depends on the language. So these are called syntax. And programming language have errors as well, but errors are generally a lot more but generally errors are different because the program will actually stop working if you have an error. Most of the time they do anyway, sometimes they don't, but sometimes there's something you didn't want to happen can happen, which can be an error. But most of the time the program actually stops. Okay, let me give you a Python example, which is probably the simplest language in the world. So I've highlighted a few things. So variables are blue, functions are yellow. So here we have number 1 equals 5, number 2 equals 10, print number 1 plus number 2. So this creates some data called number 1 equal to 5, creates another bit of data equal to 10, and then prints, add them together, and the result will be 15. It will show you 15. This is an extremely simple example, and Python is quite a simple language, so it's quite understandable what's happening here. If I write the exact same code in C, we can see that C is a bit more complicated than Python. So this is the exact same code in C. At the top we have this weird thing called include stdio.h, which is basically just the standard library which we use to print and read from the console. So if we want to write something, we have to include this. Then we have int main, which is basically a function. The main function is where programs start. You don't really have to deal with this in Python because it does it for you, but in most languages you have to write this. So main is where the program starts. It returns an integer, and integer normally means if it returns 0 then it's a success. You can return something from a function, but anyway. And then we have exactly the same thing. So we have integer, so we have to name what it is. So int stands for integer, meaning whole number. The name equals 5, and then we have to use a semicolon to separate instructions. So we have int number 1 equals 5, int number 2 equals 10, and then we print f, which is just a way of printing, and then we have to have this weird %d, which just tells the compiler what we want it to show, because it could show, like, maybe we're specifying that we want it to show text here, which is why we have to do this. As you can see, this is a lot more complicated than the Python version, but generally it's doing exactly the same thing and probably would generate the exact same code when you actually compile a program. So C is considered what's called a low-level programming language, which basically means you have more control, but it's also harder. So it's harder, you have more control, but you also have ways to make errors, whereas Python is a higher level language, meaning you have less control, but it's easier to learn. Errors and rules. So probably the biggest difference between errors and rules is that it's kind of optional in regular languages to follow the rules. It just sounds weird if you don't. For example, you could say, we wasn't doing nothing. You could say this, some people talk like this in England. Technically you should say, we weren't doing anything, to avoid the double negative and conjugate with we, but it's still understandable to do this, and nothing bad really happens. It's just people think, like, well, that's a bit weird way to say stuff. That's all, it just sounds weird. Nothing bad happens. However, if you have an error in a program, normally it stops working entirely. So you have to avoid them most of the time. Here's an example in C#. So static void main. Void basically means a function that returns nothing. Static, we can ignore that. That's a bit advanced. But so here we have number equals 1. So we create a variable, which is an integer, a whole number, and we set it to 1. And then we redefine number as text, in text. This will give you an error because it's first a number and then you're setting it to text, which is a completely different data type. It has a different size, and the program won't understand what you want in this situation. Do you want text? Do you want a number? Like, why have you called it a number? You've set it as an integer, which is a number, and then given it text, so it will be confused and give you an error. Here's another example. This is called an index out of range exception. So in this example we create what's called an array. An array is basically multiple variables or data next to each other. And you can create you can normally create as many as you want, but with an array you need to specify how many. So here we have five numbers stored together next to each other, and then in the next line we say numbers, meaning the array, and we use this square brackets to access the number we want, and we say 5. The problem with using 5 is it's actually out of the range. So if we show you how this looks in memory, we've basically created 5 variables, 5 sets of data next to each other, and the index actually starts at 0. 0, 1, 2, 3, 4. At the bottom you can see the binary representation of what it would actually look like for computers, but we would see it as numbers. You see there is no fifth element here. There's 0 to 4, even though we said there are actually 5, but we start at 0. So you can't say numbers 5 because it doesn't exist. And this could, in this situation, you could be accessing memory that you shouldn't, which can cause errors, which can cause security breaches in some situations. So in most languages they stop you doing this just for safety reasons. For example, you could do this to log into a website if there's some kind of error. So it can cause security breaches. Most of the time it just crashes the program. So one of the main reasons we need to specify so much and be specific and follow the rules in programming languages is simply how it works, how programming languages work. So computers run on something called machine code. Machine code is basically binary. It's just ones and zeros, and we can't understand it at all. It's almost impossible for humans to understand what machine code is doing. Instead, what we do is we create a language, which is like a set of rules that we need to follow, and then we rewrite that in that code, and then we convert it into machine code. And as it's a program that goes through a file, it needs to know the rules because it can't guess what you're thinking. That's the main reason why you have to be strict and follow the rules. Probably the lowest level language that exists that's not machine code is called assembly. And lots of languages will actually turn your code into assembly and then run it. Assembly is one of the oldest languages that used to be done on like sheets of paper, which used to be done on punch cards, like physical punch cards. But here's an example of turning C code into assembly. So here we have just simply, we're creating two numbers and we're adding them together. That's all we're doing. Again, before, so we're number 1 equals 5, number 2 equals 10, int result equals number 1 plus number 2. So we're adding them together, which should be 15. If we turn this into assembly, we can see how complicated assembly is to learn in comparison. So this is the assembly code that you get, and it would depend on the operating system as well. The operating system will be different because assembly will depend if it's Windows, Mac. I don't even really understand assembly code that much. I can understand it a little bit. For example, this line here, move 5 into this. We're putting 5 into this memory address, and we're putting 10 into this memory address here. Generally, it's a lot more complicated because you need to know registers. You need to know locations on a processor, and it depends what processor you're using and what operating system you're using. So, for most people, writing in assembly is extremely difficult, or writing in machine code is impossible. So instead, we create simpler programming languages that we use to convert into that, so it's a lot more accessible to the average person. If we go through the steps of how we turn the code that we write into machine code, it's something like this. But this is an oversimplified version. So we take the original language file, and then we go through the compilation phase, which basically goes through each line and converts it into something. It could be assembly, it could be another form of code, but we convert it into something that the computer can actually run. Then we look through the assembly code and try to optimize it. For example, in the previous version I gave before, where it was adding two numbers, what the program will normally do, the compiler, will simply it's kind of a waste of time to do this. If you know the value of the first number, you know the value of the second number, then you shouldn't create an address, create another address, put another address and add them together. It's wasting time. So what you should do is just simply work out the result and put it in the actual. So what normally happens is they work out the result finally and just put the final result in. So here it would probably just say add 15 and put it in this memory address is probably what it would do, because it's optimizing it. It doesn't want to waste time. Then we have what's called the linking phase. So the linking phase is simply, if you have multiple files, you need to put them together. So you have to compile multiple files, put them together. If you only have one file, then of course this would be skipped. And then you create an executable, or it depends on the operating system. Executable would be Windows. So as the compiler needs to be able to understand what you want, it can't guess, it can't work out from context. You need to be specific and follow the rules, which is probably the main difference between programming languages and regular languages. You don't have to follow the rules in everyday speech, but you do in programming languages. Let's talk about the difference in learning. This is also very different. So with learning languages, you need to read a lot of words. There are thousands of words. You also need to focus on pronunciation. How do you pronounce these words? You also have to listen. You have to listen to what people are saying to understand what they're saying. And you need to speak. Programming languages, you don't have to speak. You just read and write. That's all you do, read and write. There's no pronunciation. There's no speaking. There's also less words. But what mostly differentiates programming languages from learning regular languages is it's more active. You're more writing things. You write more than you actually read in. So when learning regular languages, you're reading thousands of words, like you're reading books, you're reading articles, you're reading words constantly. In programming languages, it's more you're more writing code. You're writing things, trying to make things, experiencing errors, trying to figure them out. You're more involved in the process, and you don't have to read thousands of lines of code to understand it. Oftentimes you can just use what you need for whatever task you're doing. That's all for this video. Let me know if you have any comments or if you liked me talking about coding. Of course, I'll still make regular language videos. Just wanted to try something new. Thank you for watching, and I'll see you guys soon.